All right, hello stats. This is your first of three. Mr. Yak is either at home or having surgery videos. So this is for Thursday, October 14th. I will be at home, quarantined away from you, in prep for getting the foot sliced open tomorrow. So, and honestly, this is good. This is a good video. We're going to do this all in one video. Chapter 9. Chapter 9 is the last of sort of the literature chapters here. We only have a few of those, and they're all in the first semester. And chapter 6 was very much like that. So though there were some cool ones we did with some data there. And you're going to have an in-class assignment when I am back with you. It's either going to be on Wednesday or Thursday, the 20th or 21st, FYI. So I might actually just use this video and just have kids watch it in the future. So producing data and experiments, that's very important, especially if you go into a field where you're going to have to do a lot of experiments, which quite honestly is a lot of them. So you need to know how to conduct an experiment correctly. I mostly look at, descriptive stats, things where we already have data. I don't need to do an experiment type of thing, or the race is the experiment, the baseball outcomes, there's an experiment. But some of you might, so hold on to this. You'll learn about it more in your actual preparation for your jobs later. But this is a useful chapter. Again, I like just crunching that data. So, what do we got here today? We have Crystal Light Pure Energy, yes, as a sponsor. We have Noon Electrolytes, hydration, water supplements there, put into your water there. And this one has energy for a recharge. I'm a fan then. Cliff Bar. Seasonal flavors, peppermint bark. Mr. Yak will not say no to this, or the spice pumpkin pie as a Christmas gift. Hint, hint, wink, wink. We're planting 1 million trees, which is good for my classes. We can produce more of these packets then. Hey, Laura Bar. Just 3 real ingredients on this one. Of course, we have our in-house coffee sponsor, Coffee Cup there, Illinois, home, south of Chicago. All right, again, God's country there, central and boom, South Illinois. That's what we're talking about. Whoa, folks, what do we got here? We have an in-class studio here. Okay, obviously I miss teaching you over these 3 days, so there we go. My daughter's plush toys. We got the Billikens over on the left, and we got an assortment of cats and other animals there in the middle, and the sponsor for Friday the 15th and for the next 2 months is the Knee Rover. Yes, there is my fantastic scooter I will be using, and Stuart the Minion is currently keeping it safe. He is my primary teaching assistant. Got to have those minions on board. Anyway, he's our number one TA for today. All right, so you have this packet. Read with me. You're going to jot down some notes. Experiments. All right. An observational study observes individuals and measures variables of interest, but does not attempt to influence them. Okay, so just sees what happens. In experiments, it does have some influence. The purpose of an observational study is to describe some group or situation, so it observes what happens. All right? So, you can highlight this, a lot of highlighting here. An experiment, on the other hand, deliberately imposes some treatment on individuals in order to observe their responses. The purpose of an experiment is to study whether or not the treatment causes a change. An observational study, even one based on a statistical sample, is a poor way to gauge the effect of a treatment. It is a poor way to gauge the effect of a treatment. To see the response to a change, we must actually impose the change. When our goal is to understand cause and effect, experiments are the only source of fully convincing data. All right, so here's an example. You got people you can put in treatment groups, and whatnot. But I think, so this book does a good job of, off to the side, sometimes it has something. A sample survey of journalists and scientists found quite a communications gap. Journalists think that scientists are arrogant, while scientists think that journalists are ignorant. All right, we won't take sides, but there's an interesting result from the survey. 82% of scientists agree that the media do not understand statistics well enough to explain new findings in medicine and other fields. I'm going to have to agree. We've talked about that, how data can be manipulated. You need the full data set. You need to look at categories. And after this class, you can be a better consumer of data. We have a math deficiency, and this class can help you get to the numbers and analyze them in an effective way. Confounding, what does that mean? And we've talked about lurking variables before. Two variables, explanatory variables or lurking variables. Again, explanatory are predictors, X's are confounded when their effects on a response variable can't be distinguished from one another. All right. Observational studies of the effect of one variable on another often fail because the explanatory variable is confounded with lurking variables. All right. So we'll take a look at some of those in a second. Now, I might not write down something, so pay attention to what I say and write this down. Cell phones and brain cancer, that was definitely, a concern, maybe 20 years ago. First time we're like really putting something directly to our ears like that for a long period of time. A study of cell phones and the risk of brain cancer looked at a group of 469 people who have brain cancer. The investigators matched each cancer patient with a person of the same sex, age, and race who do not have brain cancer, then asked about the use of cell phones. This was an actual study. Result, our data suggests that use of handheld cellular telephones is not associated with risk of brain cancer. Is this an observational study or an experiment? It's an observational study. All right, they observed what happened. All right, they didn't let one group use cell phones and the other not. They just asked questions. All right, what are the explanatory or the predictor variables? So the predictor variable is use of cell phone. How much did you use it? How many hours? You could have low use, high use, moderate use, no use. That is the predictor variable. And the response variable, it's a sad one here, but it's whether or not you got brain cancer. All right. Teaching Economics, an educational software company, wants to compare the effectiveness of its computer animation for teaching about supply and demand curves with that of your standard textbook presentation. The company tests the economic knowledge of a number of first-year college students. Economics is a great major. I would highly recommend that. Then divides them, or at least get a minor in it. My wife really liked, I think she took macro and microeconomics. Then divides them into two groups. One group uses the animation and the other just studies the text. The company retests all the students and compares the increase in economic knowledge in the two groups. Is this an experiment? Yes. Why is it an experiment? Because they had one group use the animation and they said to the other, you're using the textbook. Okay, they imposed something on them. All right, so you're going to either use animation or you're going to use the textbook. They had a control and a treatment group, which you'll find out in about a second. What are the explanatory variables? The predictor or the explanatory variables is whether you use the animation or whether you used the textbook. And the response variables is how well you did, your performance. Effects of binge drinking. A common definition of binge drinking is 5 or more drinks at one setting for men and 4 or more for women. An observational study finds that students who binge have lower GPA than those who don't. Suggests some lurking variables that may be confounded with binge drinking. All right, so obviously binge drinking, not something that's going to have any sort of benefits on your health or probably your grades, but there's other people that are prone to binge drinking might also just be prone to missing class and doing other things that have an effect on their grades. There's just too many other variables in there that would have an effect on GPA. I mean, you can just think about So many other ones. Your health could be poor. You miss more classes because of that. You don't study enough. Your memories are just so much. Again, people who are more likely to do that might, just be more likely not to study, not show up to class, and so forth. So many other lurking variables. Subjects, factors, and treatments. Let's turn the page on that. All right, so individuals studying an experiment, often called subjects. Subjects, individuals. Your sample, particularly when they are people. The explanatory variables are called the factors. The explanatory variables in the experiment are called the factors. And a treatment is any specific experimental condition applied to the subjects. All right. This is pretty interesting. You might want to read that there. All right. The Bucharest, that is in Romania, early intervention projects. A lot of orphanages in those old USSR states. So this is a very interesting experiment. All right, so look at that. Again, just a lot of good literature that you can read. Here we have people being put into different treatment groups. Here we're going to apply our knowledge. Ginkgo extract and the post-lunch dip. All right, I used to get tired as my junior year. I remembered a lot. Had U.S. history, which I did really enjoy. Second semester, but right before it, I had lunch. And my lunch in high school was not the healthiest. So I would eat a bunch of, food that wasn't exactly going to energize me. And man, I would always fight off sleeping in this class. Even though I really enjoyed it so many times, I would almost doze off. Post-lunch dip is the drop in mental alertness after a midday meal. Now, the type of meal you have can definitely affect whether or not you're going to have this dip. Does not happen to everybody. Does an extract of the leaves of the ginkgo tree reduce post-lunch dip? That is some healthy caffeine there. Assign healthy people aged 18 to 40 to either take this extract or the sugar pill or a placebo. After lunch, I asked them to read 7 pages of random letters and to put an X over every E. Count the number of misses. So this is very interesting. So for each of the following experiments, identify the subjects, the factors, the treatments, and the response variables. So a few years ago, here's what I wrote. Subjects are the healthy people aged 18 to 40. The treatments are the ginkgo extract versus the placebo pill. What do you get? All right. We have a single factor. You either have the extract versus nothing for improving the focus. Response variable is proficiency on the letter activity, the mental alertness. All right. Again, some of you might have to write this up one day, like everything in it, in some sort of documents. Here's my study, and here's why it's important. Ability to grow in shade may help pines found in the dry forest of Arizona resist drought. How well do these pines grow in shade? Plant pine trees and pine seedlings in a greenhouse in either full light reduced to 25% of normal by shade cloth, or light reduced to 5% of normal. At the end of the study, dry the young trees and weigh them. Subjects, pine seedlings. Treatment, what type of sun? Full, 25%, and then 5%. Single factor, it's the amount of sun. Response, it is going to be the weight of the trees. That is a W. That does look like an M, but the W and the E got together there. That's the weight of the trees. All right, it's probably the last one here. Student project measured the increase in heart rates of fellow students when they stepped up and down for 3 minutes, the beat of a metronome. The step was either that tall, half foot, or basically a foot, and the metronome beat was that many steps. Okay. 5 students stepped at each combination of height and speed. Use a diagram. Anyway, subjects are the 5 students. The treatments are 2 different heights of steps in the 3 different metronome beats. Factors, step height and beats per minute. So you have 2 steps. You have 2 different factors here, and the response was the increase in heart rate. All right. So that is pretty good. You can have an idea of what's going to increase it maybe the most. You can think about that. All right. So let's talk about this. Comparative experiments. Similar students takes course online. So first group is a control group. Most well-designed experiments can compare 2 or more treatments. All right. Part of the design of experiment is description of the factors and the layout of treatments. So we'll talk more about a control group in a second. An experiment that uses both comparison of 2 or more treatments and random assignment of students to treatments is a randomized comparative experiment. All right, so here's an example of a randomized, we lost the Cliff Bar. Okay, you have a random assignment, group 1, group 2, treatment 1 online, treatment 2 classroom, and then you compare their GMAT scores. That's the test you take to get into graduate business school. All right, in a completely randomized experimental design, all subjects are allocated to at random among all the treatments. Okay, and here you have an example there. Simple random sample, SRS, we'll see that all the time now. On out, you can use from chapter 8, that table B. You can use any stats program as well. They can give you a simple, like R, when we eventually use it. We'll give you that as well. Effects of TV advertising. So like go to table B, line 130. We talked about that on Tuesday, the 12th. All right. To assign them, you go 01, 02, all the way to 36. And you put them in their different groups. All right. So let's keep going here. Almost done with this packet. This page here, 233. The basic principles of statistical design and experiment are: control the effects of lurking variables on the response, most simply by comparing 2 or more treatments. Randomize. Use chance to assign students subjects to treatments, and use enough subject in each group to reduce chance variation in the results. Sample size equals large. That is the best. And we're going to talk about this a lot in the second semester. Statistical significance. The observed effect so large that it would rarely occur by chance is called statistically significant. And what we're going to do in the spring, which makes the spring a little bit more challenging, because not only do we get different numbers of importance, test statistics, but we have to describe what they mean. So we're going to say it is or it is not a statistically significant result. That is what we're going to do. All right, so you got a few at the bottom there, and then I got a few more that I want to talk about. Here's what's very, very important, and it's vital in medicine: a double-blind experiment. And they'll even tell you when you're looking at like some research or whatnot. I've talked to you in 2012 when I was having my issues with Crohn's, looking to switch medicines and whatnot. I looked at how different things were doing, how different drugs were doing, and the experiments they used. So in a double-blind experiment, neither the subjects nor the people who interact with them know which treatment each is getting, like who's getting the actual medicine and who's getting the placebo, the sugar pill. Why is that important? Think about the researcher. I mean, they've spent 4, 5, 10 years developing this medication. I'm very interested in the MAP bacteria vaccine for Crohn's. They think they could basically cure Crohn's disease with this vaccine. They gave the first shots a few weeks ago. If you're a researcher, you've been working 10 years on this, and man, you put your heart and soul into it, this is all you've done, and you go to somebody and you know that you're giving them the actual drug, and not the sugar pill, and this person's just like not responding well, you might be led to believe like, hey, are you sure? Are you really having the side effect? Are you sure you're not feeling better? You might use more leading questions. You might get frustrated. You might be like, oh, you know what? You've got other health issues. This is not going well for you. I think we should eliminate you from the study because this should be working. All right. You don't want to know. You don't want to know, so you don't lead them with certain questions. Also, if you know that you're taking the drug, you might, give them different results. You might be like, yeah, I'm taking the drug, so I'm obviously feeling better, when maybe you're not. You might be also led to not be totally honest with how you're feeling, okay? So it is very, very important that neither the subjects or the researchers, nor the researchers know who's taking the placebo and who's taking the real medication. As men age, their testosterone levels gradually decrease. This may cause a reduction in lean body mass and increase in fat and other undesirable changes. So, do testosterone supplements reverse some of these effects? A study in the Netherlands assigned that many men aged 60 to 80 with low or low normal testosterone levels to either a supplement or a placebo. This was in JAMA, Journal of American Medical Association. So that's a big one. Describe the study as a double-blind, randomized, placebo-controlled trial. What does that mean? Well, first off, neither the researcher nor the subjects knew which group they were going to be in. All right, so placebo control, that means medicine versus someone's not getting it. Okay, obviously they were put in random in their groups as well. Okay, so that is what, if you read that's what that means. And, okay, folks, this is just a page of other facts there that you should definitely read. All right. Everything that we talked about, it's got a little bit more there, so read that. This, again, will become very, very important. I put at the bottom, highlight that. This will become very, very important if you go into fields that do a lot of studies. Okay, so now we have the check your skills at the back, and we just have 2 short pages of this. So take a look here. The Nurses' Health Study has interviewed a sample of more than 100,000 female registered nurses every 2 years since 1976. The study finds that light to moderate drinkers had a significantly lower risk of death, significantly lower than either non-drinkers or heavy drinkers. The Nurses' Health Study is an observational study. They are observing what is happening. All right. 920, what electrical changes occur in muscles as they get tired? Student subjects hold their arms above their shoulders until they have to drop them. All right. Meanwhile, electrical activity in their arm muscles is measured. This is, what is it? So it's an experiment, right? And it's uncontrolled. They're not like making one group not do it. So it's an uncontrolled experiment. Doesn't mean like it's a bad, like, oh, that's uncontrolled. It's an uncontrollable kid. That doesn't mean bad. It's just, it's an uncontrolled experiment. They're measuring, they're having them do something for sure. They're like saying, hey, you're doing this. All right. Whereas in the other one, they're just observing what's going on. So this is an experiment for sure. But it's not like one group is doing one thing while the other is doing another. All right. Can changing diet reduce high blood pressure? Obvious answer, yes. Vegetarian diets and low-salt diets are both promising. Men with high blood pressure are assigned at random to 4 diets. It's 2-factor, normal versus vegetarian diet, and unrestricted versus restricted salt. All right. And 922, an experiment of the previous exercise. 240 subjects were labeled 001 to 240. After Tuesday, you know why that's the case. So you assign 60 to each one. That is a completely randomized design. All right. Then Take a look at 923. An important response variable in an experiment described, and that must be, what are you looking at? Change in blood pressure after 8 weeks. Change in blood pressure, that is what you're looking at. All right, so you have 36 headache patients. You want to choose 18 of them. You can use table B. You're going to label them 01 to 36. 36, that's a 2-digit number. That's why it's got to be 01. And then you're going to use table B to choose 18 of them. Community intervention trial for smoking cessation. Cessation means stopping it. All right, asked whether a community-wide advertising campaign would reduce smoking. The researchers located 11 pairs of communities. Each pair, similar in location, size, economic status, and so on. One community in each trial participated, and the other did not. Okay, it's kind of like matching, Litchfield and Hillsborough type of thing. They're similar size, right next to each other. We're close to where I live. You could choose, Fallon and Edwardsville, or Shiloh and Glen Carbon type of thing. So this is a matched pairs experiment. To decide who should get the advertising, what could you do? Choose it who's going to help pay for the campaign. There's going to be a little bias there, right? Both B and C have a little bias there. So A, just toss a coin. All right, then we got, this is it. Marketing class designs 2 videos, advertise an expensive Mercedes sports car. They test the videos by asking fellow students to view, random order, and say if it makes them more likely to buy the car. Mercedes should be reluctant to agree that the video favored in the study will sell more cars because results from students may not generalize to the older and richer customers who are most likely to buy a Mercedes. Okay? That's true. Your college kids, unless you invent a new app, you're not buying a Mercedes. All right? So there you go. It's like, if we ask the school in the next election, who are you going to vote for? Those results don't matter because you can't vote. All right? Anyway, that is this video, and that's Chapter 9. Thank you for watching. Look at your review homework set. We will talk more in a different video with Chapter 10, where you will do some calculation tomorrow. This is Yak Math Videos, signing out.